The next part is derivative of Trigo functions. Firstly, we need to know that differentiate sin x is cos x, differentiate cos x is negative sin x, differentiate tangent x is sec square x, differentiate cot x is negative cosec square x, differentiate sec x is sec x tangent x, and differentiate cosec x is negative cosec x cot x. Example number 17 on page 14. Part A. We have y equals 2 sin x minus 3 cos x. So, dy dx equals, we copy the coefficient 2 and differentiate sin x. Differentiate sin x is cos x. And then minus 3. Differentiate cos is negative sin x. So the answer is 2 cos x plus 3 sin x. Part B. Y equals 4 tangent x minus 5 over x. We can write y equals 4 tangent x minus 5x power of negative 1. We change to negative index. And then y prime equals to, for the coefficient, differentiate tangent will be sec square x, and minus 5 the coefficient. For this case, we need to use power rule. So we bring down the power, negative 1, we write x, and we reduce the power by 1. So negative 1 minus 1. So we will get 4 sec square plus 5x power of negative 2, or equals 4 sec square x plus 5 over x squared. Next, we go to derivative of sine u, cos u, tangent u, and so on. From previous part, we just have sine x, the angle is x. But now the angle is u, and u is a function in terms of x. So differentiate sine u will be cos u, and we need to differentiate the angle dx du. Differentiate cos u is negative sine u, differentiate u. Next, tangent u will be sec square u, and then differentiate u, and so on. Example 18 on page 15. Part A. Fx is cos 5x plus 4. So f prime x equals, differentiate cos is negative sine, and the angle is 5x plus 4. And next, we need to multiply by the derivative of the angle, d dx of 5x plus 4. So we have negative sine 5x plus 4 times 5. Or the final answer is negative 5 sine 5x plus 4. Next, derivative of sine u power of n, cos u power of n, and then tangent u power of n, and so on. For this case, we need to use the general power rule, which is we bring down the power, so we will have n. Next, we copy the function and reduce the power by 1. Next, we differentiate the function itself. For this case, we differentiate sine u. So this is the derivative of sine u, and so on. We go to the example. Example 19 on page 16. Part A. Fx equals sec square x. And we can write sec square x as sec x square. So this is the equivalent form. So f prime x equals, okay, first we bring down the power, so we have 2 times, we copy the function sec x and reduce the power by 1. Next, multiply with derivative of the function itself, the Trigo function itself. So differentiate sec x. So we have 2 sec x now becomes power of 1 times differentiate second. Differentiate second is second x tangent x, and equals to sec square x tangent x. Next, example 20 on page 16. We go to part C. So for part C, we have x, a linear function, times sine 1 over x, a Trigo function, and in multiplication form, meaning that we need to use product rule. So for product rule, we state what is u and what is v. U is x and v is sine 1 over x. Next, find u prime. U prime is 1. And v prime is, differentiate sign is cos. Cos The angle is 1 over x. And then differentiate the angle 1 over x. And next, we will get cos 1 over x times 1 over x can be written as x power of negative 1. So we differentiate x power of negative 1. We will get negative 1 x power of negative 1 minus 1. So we have cos 1 over x times negative 1 over x squared. And the final answer is negative cos 1 over x divided by x squared. So this is your V prime. So f prime x equals, we use the product rule formula, which is VU prime and then plus V prime U plus here. So we will get sine 1 over x times 1 and plus x times negative cos 1 over x divided by x squared equals sine 1 over x minus cos 1 over x divided by x.